Welcome to today's webinar. We'll be talking about GenAI app observability on Azure with Datadog. So in terms of GenAI, what we're talking about here is generative AI. So what we're going to be talking about is like autocomplete and what that looks like for applications that you might be deploying internally for some of your stakeholders. Before I begin, let me introduce myself. I'm 𝗦𝗽𝗲𝗀𝗀, I'm a senior tech evangelist at Datadog. I bring over 20 years of industry experience to the role, and recently I was a senior operations engineer at Samsung. So I've been using Datadog since about 2014 at a company called Stem Cell Technologies. I've been using it extensively, for example, at Samsung to monitor data systems. We did things like Kafka, Hadoop, etc. And I would often be that link between operations and data scientists or developers, wherever I worked. And I've been doing that hard work of explaining complicated things in a simple fashion for most of my career. So taking complex topics and trying to boil them down to something that you can grok, that you can understand. And that's important because these days things are getting more and more complex. Not only have you moved probably from on-prem to a little bit into the cloud, but also you're trying to monitor both of these environments at the same time. Now, you used to maybe have one vendor. For example, I used to only deal with Microsoft and maybe a hardware vendor, be it Dell or IBM or what have you. But these days, the amount of vendors that you have to deal with is also increasing. And on top of this, you've probably got computing units, so more servers, maybe more laptops, more desktops that you're dealing with as well. On top of which you're involving more people. So your team might be getting bigger, but also you may be spilling over into other teams or helping other departments. And on top of this, the number of large language models that you may be using are increasing as well. So gone are the days where GPT 3.5, for example, was the model that everyone reach to in order to get everything done. And these days, I guess it's more around multimodal LLMs as well as small LLMs or larger LLMs, some that have larger contexts, some that are faster, some that accelerating things like voice, for example. At the same time, the processing power of all of these computing units that we're getting out there, including iPhones, are getting more and more fast as time goes by. So some of these technologies that we're talking about can actually be offloaded a little bit to the device, as well as using the cloud and your back end or front end. So a lot going on, and it's difficult sometimes to figure out where slowness, latency, or errors might be coming from. All right, so in a complex environment, Datadog's here to help. We're a unified observability platform that provides full visibility into the health and performance of each layer of your environment at a glance. Datadog allows you to customize this insight to your stack by collecting and correlating data from over 1,000 integrations, all in a single pane of glass. We span end-to-end from your infrastructure and network to your application services, all the way down to your end users. And, pardon me. And also of note, we were named the leader in the Gartner 2025 Magic Quadrant for observability platforms, which is what we'll be touching on today. Observability, that's monitoring, measuring, and tracking our GenAI applications. Okay, so let's talk about the problem. So now that we've talked about who I am, who I work for, let's talk about what I've been up to lately. So this is going to be fictional for the most part, but I think some of you are probably having this happen at the companies that you work at now. So maybe a skunkworks or hidden project led by a singular team or dev, trying to figure out if maybe you could take like an internal knowledge base or SOPs or what have you, standard operating procedures, and put that into something like an agent, a chat app, maybe an MCP server that you can help your company with in terms of internal docs and services, as well as reaching out to those LLMs and maybe routing between multiple LLMs or maybe routing between multiple models within one LLM provider. So today we'll be talking about OpenAI and Azure OpenAI, but also within those systems, you can have multiple models that are served. So we talked about GPT 3.5 before. There's also GPT 4.0 and maybe 4.5, on top of which there's Codex. And then on the Microsoft side, there's also all those Hugging Face models that you have access to through Azure OpenAI as well. So there's quite a bit of models that you can choose from, and they all have their pros and cons. So the question is, what do we do with all this data? Internally, and again, this is fictional, we had a chat app, but our boss wanted to ground that data with corporate knowledge. So basically, when people use our internal application and they go, say, looking for something, they may pull up web results, but probably we also want them to pull up things like maybe SharePoint or maybe something within our database, or perhaps we've got like a pile of PDFs, which is the example that we'll be using here. And using that pile of PDFs, maybe when we search the LLM, we can get back some of that data as well. So if I search for myself, for example, I'm not a very popular person in GPT 3.5, it might not find anything, but it could be if I add data to that, or if I fine tune that model, then I could find some interesting data details about myself. Again, this depends on the cutoff and the model, but we'll get into that in a moment here. So this is the architecture of our RAG GenAI app. Now, RAG stands for Retrieval Augmented Generation, which really might not help explain what's happening. So essentially what you'll do is, typically when you talk to an LLM, you'll send a query, so a prompt, and that prompt will be mixed with the system prompt and maybe some context. And what you'll get back from the database, what you'll get back from the LLM is something that's in their corpus, essentially. So the LLM will have a bunch of data that it's been trained on, and if what you're looking for is in that data, then it can essentially give you an answer. Now, that said, there's some data that might not be in that corpus, and what we can do is during retrieval time, so when we're going to give that answer back, what we can do is actually go and retrieve something from a vector database, find the answer in there, and use the LLM, and then give you an answer. Now, I'm mentioning a few things here. So we talked about RAG and what the database does in there, but I also just mentioned vector databases. So vector databases are interesting in that they're generally, or they are, a combination of a bunch of vectors. So these are numbers that are in n-dimensional space. So we'll talk about 3 dimensions here for a moment, just to make things a little bit easier. But you can imagine that we've got maybe 2 words, say dog and cat. Now, dog and cat are different, but they're also animals, they're mammals, they have fur, etc. So they've got some things in common, which will put them in there. But also on the far end, you might have something like car. And car might be similar to dog and animal in that they're things that we deal with on a regular basis, but also it could be that the proximity between dog and cat on the animal spectrum is very different than the car, which might be way over here. So in terms of that proximity search, that's where the vector database comes in. And we'll talk about this in a bit when we're talking about those SOPs or looking up those different pieces of information in our database. But at the very base level, we've got a front end, and then we've got a back end. That back end may actually have something like a model router. So imagine it's talking to OpenAI as well as Azure OpenAI, and maybe hitting Hugging Face models, or maybe also hitting something like GPT Codex. So it might be looking up current models as well as some that are a little bit specialized, and it depends on the query that's come in. At the same time, if it finds that there's something that could be in the database, it can look that up using our vector database, and if there are answers in there, mix those with the LLM answer and get it back to us. So this is a very simplified architecture, and this could go many different ways. I think RAG is one of those patterns where you talk to the database may depend on your architecture. So you might hit an LLM that then routes, then hits the database and hits another LLM and comes back to you, similar to what we're doing here, or it could be straight through and just talk to the database and then call the LLM after. It really depends what you're doing. But the key here is that we're mixing company data, that's private data, with LLM data, that's the data that's in the cloud or provided by the host or in the model, and giving you the answer that combines the two. Okay, so a big infrastructure, but the question is, what happens when we've got a problem here? So we've got some issues on the gRPC client in the middle on the recommendation server. You can see if there's 8.27% errors. So there's quite a few errors going on here. The question is like, how do we figure out where those problems are when all we're looking at the hosts, or maybe all we're looking at are resources in Azure? So often the teams responsible for these components aren't working in the same tool. They might not even be speaking the same language or using the same coding language. And that fragmentation will lead to time, context switching, and guesswork when it comes to that root cause analysis. And this is why surface level monitoring is often not enough, especially when it comes to black boxes. So we need observability that spans code and database queries and gives us that context to connect and cause and effect. We set up an app, it's deployed to prod, everything's going swimmingly, but I just got paged about latency in my app. What do I do? Is this panic mode? What do I do from here? So let's walk through this familiar moment to see if you can remember that sinking feeling in your stomach. You just shipped a config for the vector database for your RAG app in production. Everything seems fine until you notice latency creeping up in one of your doc ingest jobs. Now, I'm in here troubleshooting with you. it's not a full outage. We're just getting started, but the performance is getting worse and worse. And I need to make sure that those jobs can keep up with the rate of change in the docs in order to make sure that the data is not stale. Because what we don't want is someone to look for data and pull up like SharePoint data from a year ago, or maybe PDFs that are SOPs that are no longer valid. So imagine training somebody on like a standard operating procedure, but it no longer applies to their environment. So not an ideal situation. So I can see what's going on, but I need to figure out why. And this is where things could get complicated. So let's talk about the repositories, so the code that we've deployed here. Now, this is GenAI generated. I apologize. There's a lot going on in this repo, but the main thing I want to get across is that it's a large code base. So typically it's not something that you can ingest into your RAG app, and it can be difficult to reproduce issues, and that can lead to high recovery time. On top of which, since there's multiple fictional people working in this application, there's multiple deployments per day. So it could be difficult to track any change to any particular deployment because they might happen within the same minute, sometimes the same second. It could be that jobs released multiple times on multiple branches from your repo. So it could be that it's difficult for you to figure out just based on time what's actually happened. So we can't say like what deployment happened today. It might be what deployment happened this hour or this minute because there's so many going on. And on top of which, those jobs that are releasing your code, be it in prod or dev or staging, these can lead to high CI/CD costs as well. So if we're running multiple jobs for no reason, or if we're doing multiple ingests or changing schemas where we don't need to, that can lead to a lot of overhead and a lot of basically guesswork and troubleshooting. Okay, so that first challenge might start with scale. So these applications could be made up of thousands of lines of code written by different teams, as we mentioned, contractors, legacy, all types of stuff, things that are inherited, poorly understood, and that leaves us with blind spots. So the question is, with these spots, with these black boxes that we can't really figure out what's going on, where do we need to look first? So the question is, when you're thinking about what's slow, I guess the answer to that is look at your app performance. And then when you want to think about why it's slow, this is when we look at our code and our database. So that's the theme of today's talk, how to go from identifying what's slow to understanding why it's slow with the data that leads you directly to the line of code or the query responsible. So think about our schema, our database config, maybe some queries, or maybe some application code that calls those. So maybe we've got some .NET queries that talk to Postgres in order to pull up those vectors. The question is the latency between there. Is it a problem with the app? Is it a problem with the vectors themselves? Is it a problem with the LLM after that? So it could be in multiple locations, and it's difficult for us to ascertain which of those is true. Now, with that, let's talk about some code actually in production. All right, so we're going to talk about code performance for a little bit just to set the stage, because there are multiple factors in our app. It's not just a database. It's not just a front end. So again, our repository, our code doesn't have to behave the same way in production as it does in dev or staging, but it's going to run under real world conditions, handling unpredictable traffic, allocating memory, and consuming CPUs in ways that maybe we can't simulate. Oh no, the team got paged about latency in my GenAI app again. Okay, so if we go back to our initial example, let's look at a situation where I can look at the code itself. So again, where to look when we're looking at app performance. So what's going wrong? What do we look at in the code? So I'm going to go into a quick demo here. It's going to repeat a couple times because it's a GIF, but we're going to look at a slow trace. And that slow trace will actually tell us, or sorry, a slow service, that'll actually tell us where one of the root causes may lie, but then we'll dig in and find some more. Okay, let's look at this together. Again, it's going to be a GIF. It's going to go through here pretty quickly, but looking at our web store, for example, we can see that there's a lot of errors, but we can also see that there's a spike in time. So as we go through here, we can start drilling into each of these areas to figure out what's going on in my service. Now, also on top of this, I can see that actually there's some problems with our traces. So now looking at this, it looks like everything's fine, but if we look at the amount of time it took, this is up to 12.4 seconds. So that's pretty long in web terms. So imagine you went to a website and you refreshed the front page and it took 10 seconds to load. You might think that there's something wrong with your internet, or maybe your browser, or maybe your computer. So maybe you go troubleshooting that stuff first. Maybe you look at like updog.ai to figure if something's up or down, or maybe you start trying to think, oh, is there something wrong with my code? Did I deploy something wrong? Which environment is this in? That kind of stuff. So when you're troubleshooting an app, it might be that you don't know where the problem is, but when looking at a trace, it's often maybe not obvious, but often easy to figure out at a glance what is happening. So in here, you can see there is one error, not a big deal. It's this tiny one over here. You can see that error there, but also we can see that these spans are fairly long. And one of these here, get train, actually looks like it's got an issue, and it's part of the largest span. So it's the one that took the longest time, so 12.2 seconds. The rest of these seem pretty fast, actually, but this one took a long time. If we drill into it, we can figure out what's going on. So it's one of our compute coefficients for our training job. All right. So this is the main thing. So we're looking at the latency in our app, and this is from the front end side. But what's happening on the back end, we don't know. Is this a database issue? Is this an API issue? Is this a problem with our LLM? We're not sure. Now, the other is we can actually go through and look at the profiles of the code and see if we just recently launched a change, is it slower or faster than the code that we had out there before? And what's nice about that is in profiling, we can actually compare two points in time. And again, this isn't specific to Datadog. It's just a lot easier for us to talk about this with some graphs and examples. But think about when you deploy something, the question is, what changed? Is it better? Is it worse? We need to know those numbers before we can move on to say, actually, it's not the code that we just deployed, it's something else. Or it might be the code that we just deployed, but it's not in the code, it's something that it's calling. Okay, so for example, we've got a profile here. We can see this coefficient worker that we determined in the last slide was wrong or had some errors. We can see that it's throwing exceptions in here. And as we mouse over, we can get some details on CPU time, for example. We can see it was using 100% of at least one core, and that this is the get train span that we were looking at before. And as you drill into it, we can get all of those insights and information about what was happening to those threads. Okay, so quick demo. So sometimes it's in the front end. We got to look at what's going on there, and APM can help us there. But if we determine that the front end has a problem, but it's looking at something in the database side, we're going to have to drill in or maybe use that same time frame to start looking at our database, be it Postgres or SQL Server or what have you. So databases can be easier to manage in cloud environments, at least with managed services, but sometimes the performance trade-offs might not be obvious or unrelated to the database altogether. So it could be something slow in the database, but I'm running like an ingest job at the same time people are trying to query. Or it could be something where it's not that it's shared, but it's doing some sort of replication at the same time that I'm trying to come in, or maybe doing a backup, or with Postgres, it could be a vacuum. So let's talk about an example of a quickly thrown together database where two devs were sharing while trying to push vibe coded application to prod. All right, a full confession, our fictional app here got deployed, but we vibe coded the database backend, which I can't really recommend. So not the best moment for the team, but it was something we did to ourselves. It turns out that you can't have two people vibe coding that database infra at the same time. One of us was YOLO injecting PDFs into the ingest, into Postgres, while the other one was swapping out the container image we use for the database engine itself. So imagine you're running like a large ingest job into a database, using a database engine, but somebody else on another team has restarted that Docker container, restarted that VM host, or restarted the database server on you while you're running a job. And you don't know about it because you don't understand that other people are in there working at the same time. You're not looking at connections or queries that are running or anything else in your job system. So teams who were using the DevDB were blocked, and we weren't sure where in the 4-hour process of ingesting those PDFs we had stopped at, so we didn't really checkpoint that job either. It felt like it might be time for a different infrastructure approach, and this is maybe where Azure would come in. So we'd start looking at what Azure can provide us in terms of Postgres. Is it something like a Flex server? Is it a shared database? What have you? So let's just talk about using Postgres as a Flex server in Azure. It has a lot of benefits for what we're looking for. What we want to look at, though, are the database metrics itself. So is the database healthy? Does it have connections? Do we have people who are running queries at this point in time? Are there blocking locks, for example? So looking at database level metrics, are there people running select star from all queries, the bad queries, maybe some vibe coded queries, or they're doing inner, left, outer joins, they're doing a whole bunch of fun stuff. But at the same time, maybe after this vector database, we've got some LLM app metrics as well. So there could be something happening in terms of the embedding model that we're using, or maybe we're using like a small embedding model instead of a larger embedding model, which means that the speed is a little bit hampered. Or it could be that the provider that we're using is having an outage. Again, we might need to check some public database of outages. Oh no, okay, so sorry. While we're talking about this, it looks like something else happened in our GenAI app. So let's talk about that database, because it looks like this keeps happening, but let's look at our database. All right, so let's talk about investing a trace. So we had a trace come in and we talked about that front end a little bit, but also we know that this is heading the back end application. So let's talk about this trace. So we had someone come in and hit the admin/update user endpoint, and it had an internal server error, which again could be the front end. It's possible. And we can find the line of code here. Oh, this looks like SQL code or a SQL query, at least to me. This is definitely a SQL statement. So we've got select c.oid, c.cf name. We've got this count star from orders, where this definitely has a feel like a database query to me. So if we drill into this, we can see that there's a long wearing query at the bottom here. Sorry, I think the box is a little bit off of alignment here, but that's select under there. We can see the actual query statement itself. And then if we go into the database on its own, we can start looking at, oh, okay, there's actually quite a few things going on here. So when we look at this average duration, it looks like it used to be quite a bit smaller, and now it's increased quite a bit. And in fact, the count that we've got is quite a bit higher as well. And then we're going through here, we can start to pick up some of this database information to help us figure out which database to look at, essentially. Oh, and then we can look at our queries here, and you can see there's a bit of a map going on, but it might be that I wrote a bad query, or that I vibe coded a bad query. As I was trying to optimize things, it looks like maybe I could have done some testing beforehand. So the average cost here was 11.9 million rows. That's quite a bit of data. And then in terms of query samples that we've got, there's 34.3 thousand query samples. So we can look at all of the query samples and start to figure out, like, is it the query problem? Is it a database problem? I think we pretty much narrowed it down to query. But once we look at this query, we can start then modifying it and figuring out how it affects the database on its own. All right, so what we're talking about here is all the way to the top. We're talking about that front end, and then we started to talk about how the front end talks to the database, and then a little bit about how the database talks to the LLM. We'll get into that a little bit more here in the demos. But what I want to say is that when we're looking at what's slow, we want to look at the app performance. And then when we're thinking about the LLMs, the database, the vectors, that's why it's slow. So that's a code that putting those two together. So basically looking at the database, the LLM, and the code together, that's why it's slow. Okay, so this is, again, a pretty quick run through of the demo that we'll be talking about, but hopefully this gives you enough background on the RAG side. I noticed one question in there about prerequisites. This is basically that. So making sure that we understand what retrieval augmented generation means, that's RAG, and also understanding the vector database. So the retrieval augmented generation means that you're pulling from the database as well as the LLM if it's got private or data that you've given to it that's specific to your company, specific to you, not in the corpus of the LLM, essentially. The other is that vector database. So remember, we're thinking about n-dimensional space, but if we think about 2D space, so cat and dog, how close they are, and maybe a 3D space, so if we add a dimension of a mammal or animal, car might be pretty far away from those two animals. But if we add another dimension in terms of things that I use daily, it might be that they're all three are close. So I say hi to my cat, my dog before I go to work, then I get into my car, and then I head off from point A to point B. So it really depends on the dimension that we're looking at. So that's this vector database and the RAG pattern. Now, I've got a couple of links here. Again, if you just want to speed run through the presentation and watch the one that we do with Microsoft as well, on the right is that previous webinar recording. And if you're already in the Azure platform and you want to look at Datadog, on the left is the Datadog entry to the Azure Marketplace. Now, when you get started, you can either bring your own Datadog account if you're already a Datadog client, or if you want to, you can full on set up a Datadog account from the Marketplace.